So since there's only you and me, I will be a bit more informal than usual. I have a very partial agenda on this one. It's not, I'm not where I wanted to be, but still, I worked on two things which are unfortunately a bit disjoint. One is notation. I want a notation to be able to input recursive hypergraphs in a reasonably terse manner. And metaclaims, and what does it look like to input a metaclaim. And I did progress on the data modeling side, and that's something I want to present a bit separately. And this, it's mostly about the big question of what do the equivalence classes of concept representations look like? And that's the question that I haven't fully answered, but again, I have progressed and I want to show where I'm at. Let's start with the notation. So what I want for myself, this is not going to be the wire representation, which will be different, but this is a kind of markup that's vaguely human readable so that I can write test cases, write data sets, and somebody can read the data set and have a clue what it's about. I will assume familiarity with a lot of other technologies. I'm very used to the turtle notation of RDF, and in turtle notation, you can just put URL in angle bracket or use namespace queries. So basically namespace colon name, and you have a URI of a resource. It's not the only thing. CIDs will be there. But the most important thing, I'm going to use local identifiers. And in Turtle and most RDF systems, what you do when you say, oh, the local namespace is this, so anything that's just colon name is assumed to be in the base namespace. But here what I want to say is, no, it's not in the base namespace. It's a local variable only for the purpose of the document. And it should be translated to either a global identifier, a namespace identifier, which is also global, but most often to a CID, which I won't put in the document. So the idea is to use global namespaces as a way to create boundary between documents, but use CIDs internally. And the other thing I want to do, and these boundaries will be defined probably with JSON-LDE ID of context, which is basically saying this, in this context, this name stands for this global identifier, which again can be global URL, namespace query as in RDF, or IPLD, IPFS hash, or some other CID technique, which after all, the IPFS people don't really think that way, but they're URLs. It's a locator. It's not a server-based locator, but it's a locator. So this is what I'm setting out to do. The basic syntax, as an example, is, again, think RDF at first. We're speaking about triple, subject, predicate, object. Not everything will be a triple, but let's start with triples. And it's like, so these would be local names. And this is like YAML, except I'm saying, oh, the predicate is marked by a different prefix in the YAML file. This one is a binary predicate, which is a bit rare. Local identifiers will probably be erased and converted to CIDs. As I said, subjects are introduced with dash, and this should have been different lines, and I've been working on this a bit fast, apologies. So that should be simple enough. This triple is considered asserted in the local context of this document. If I want to to be quoted, I will use a circle or O instead of a star in the object, because the triple really ends at the object. So I can say, well, this is a quoted triple, and I'm not asserting it's true. I'm just speaking. I'm going to speak about it. Just as a shortcut, I can put the object in line if there's a single object. If there's multiple objects, I could have multiple objects here. But if there's a single object, I can do it in line. Here it's asserted, here it's quoted. If I'm doing a frame, well, a frame isn't really it's a simple object, I should say a simple subject. So in a way, that's a kind of reification. So you're saying here's a frame, and here's the different roles, and here the different subjects, which are here playing the role of object in the corresponding triples. Here's a shortcut one. Here's oops, that's a mistake. This should be in line. The subject 2, subject 3 are for the same role. So that's a mistake. And I'm a bit, oh God, this was really, I will work on this slide deck, but basically I'm a bit ambivalent with the fact that this role is really a kind of half arrow, and whereas this predicate here, it's as if it were a frame, because it has, you know, the subject role and the object role of the predicate. So it's a frame encapsulated as a binary predicate, and any predicates, it's the same notation. So maybe I want to distinguish them, but I think I can do without. So let's just go with that. Here, again, this is syntactic sugar. I can assert a frame inline. So instead of saying frame subject, if I've started by speaking about the subject, I can say, well, look, back reference with this role to this frame. So assume that there's the role 1, subject 1 in this frame. So that's a way to speak about the frame from the context of the subject. That's sugar. And there's meta statements. Here I'm mixing 2 notations. I should have introduced them one at a time. But this is really the important trick of my little YAML world, is if I have subject, predicate, object, this defines a triple. Here, if it were a dash, it would be another object. But since it's a star, we know it's a predicate, and the predicate cannot apply to the predicate. So we know it's actually a meta claim on the previous object. So it allows me to define predicate on the meta object. Another terse notation I'm working with is to do curly quote and have a kind of pseudo turtle notation that is predicate, object, comma, object, semicolon, predicate, object. But I'm less sure about that. These are experiments. But this is really the key point. The point that I have, if I have a star under a star, I know it's a meta statement. And that makes it very convenient to express meta statements. I think this is terser than turtle star, but your mileage may vary. That obviously allows me to give an ID to a triple, and then that either in line or as a meta statement, and that allows me to start assigning, making meta statements between 2 distant statements, because here I was just doing it locally. Or I could do it with a backref, of course, but still I need to name one of the statements. So I need to give an ID, a local identifier. And again, this will be converted to a CID internally, but I don't want to show CIDs. So this allows me to write it as text. And of course, there's literals. which are basically anything that doesn't have a colon or angle brackets as a full URL. So I know it's not it's not a reference, so I guess it's a literal, and or anything quoted. So that means if I have something that contains a colon or angle brackets, I want to quote it. Variants with RDF literals can be subjects. Truth values, quoted and asserted is good enough for local truth values. It's not good enough for global truth, but then we can use the angle notation to do that. That's a bit hand wavy, but I think it's logically equivalent to Turtle Star. I think it's a bit more practical, and I was hoping to write examples using that notation. Didn't get there, but it's my next step. Oh, and of course it's thank you. As I said, it should be possible to give global names to things that will be shared between documents using a context objects. Local names kept to CIDs, global names are kept and are used to share, and that would allow to translate to RDF star, I should say Turtle Star, or JSON LD star. So that's my base notation, and I want to close that. But I mean, I wanted to introduce the fact that there is progress on that and that I'll be able to have content based on that. But right now, that's not where I'm at. I'm working on the relation. So first, let's review anything, comments on the notation?
I mean, questions, but I'm not familiar enough with this kind of notation anyway, so it's more helping me understand. But in the example back there with the meta claim about the object, which part of it is having a meta claim about it? It's the subject. It seems to me, isn't it generally the subject is the thing you're making a meta claim about, something you're claiming about a separate claim or something.
Okay, so subject predicate object is the base claim. So sure. I'm saying subject predicate object.
Okay, so predicate to object is the actual claim you would be making about that other.
Exactly, that's the meta claim about this primary claim. Sorry, I thought, yeah, I should have made that clear.
Probably somebody who understands this kind of notation would be clear to them.
No, I'm building the notation. The question is the question is the need for meta claims and how do we express the meta claims? And yeah, the point is this should be both readable and terse, easy to write, easy to read once you've understood the idea. I think it is easy enough. I may be wrong. Like many, like, is this syntactic sugar adding confusion? Quite possibly. I'm very unsure about that. I'm very confident that this is a very simple trick of syntax that can be learned easily.
Here's a separate question. If you're, you know, in the case where you only have one object, you're simplifying by putting the predicate and the object on a single line.
Yeah.
Right. Couldn't you simplify even more by having the subject predicate object all in a single line, and would make reading meta claims more readable because you have essentially the full claim that's being referenced on the first line as if it were a subject, and then you have under that the actual claim.
The Turtle Star notation, what it does, which kind of works, and it's nothing wrong with it. It uses double angle brackets like chevron type to go subject, predicate, object, and then that's in chevrons and then predicate object. Very, very simple, very readable.
Right.
What I'm a bit annoyed with that is that it's difficult to stack metaclaims. Well, no, it's not that bad because it's still turtle. So you can just say, and then
Turtle's all the way down. It's nesting. It's Lisp. It's reading Lisp code.
you can go predicate object, predicate object, predicate object, comma, object, predicate, semicolon, predicate object. So it's not that bad. I do find that it's and maybe I should forget creating my own notation and use the turtle star notation, which is not terrible. There's something that bothers me about the turtle notation. I do find it, like, I find if I want to say many things about a claim, like use it in subject position and predicate position, and then I'll use it in another role, I'll be repeating that thing often. And they don't really allow a good way to give an identity to this thing. You're supposed to use it as a value object all the time. And this mechanism, is it so much clearer? Maybe not. And yes, I could totally do what you're saying. That is, do it in one line. The reason this works locally, it's because the nesting gives me, well, this is about that, but it cannot be about that, so it's about this, right? Because of significant spaces. That must be my Python upbringing, right?
Is this object 3 in this case part of predicate 2 or
it would
1?
refer to predicate 1. It would be another triple, subject 1, predicate 1, object 3.
So, but my understanding would be that essentially the subject predicate object 1 are the subject of predicate 2.
Correct. That's the
But
subject.
then how is object 3 not part of the subject of predicate 2?
Because it is not nested under this, it's nested under this. So it's an object.
I mean, structurally, I understand it, but I'm not understanding in practice how that would be. Because you're saying, for example, a claim about a claim. So like the fact that this thing is true means we should do something else. Okay, that's like a claim about a claim.
And then I'm making another claim about subject 1. I'm making an unrelated claim about subject 1. It's not related to predicate 2. It's just predicate 2.
Oh, okay, I got it. Well, yeah, I got it. Okay.
Okay.
Okay, I got it.
It's a sequence, right? I'm doing this and then I'm doing this. But
right. Well, for a claim that would be involve 2 objects normally, like we should have pizza and Chinese food.
Yes.
That would be an example of subject predicate object.
Well, this one you don't need meta claims here. It's a frame, like we should.
Right, you don't need meta claims, but
you need a frame like eat and probably a modal, a role modal, which is should, and then actor would be us, and then there would be some specification of us, and then you could have multiple objects here, or subject, whatever you want to call them, and then multiple what we're eating role, and then pizza and whatever else, right?
Yeah, I'm just not sure if I can visualize the flow of, I guess the fact that we should have pizza means we should go to Amici's. We should have and Chinese.
Okay.
It seems a little hard to,
So no, those are the questions, right? So let me try. How I would do it is there would be one frame saying we should have pizza, which I just described, and there would be another frame saying we should go to Amici's, and that's a frame. And there's another frame, yet another frame saying going to Amici's is necessary to have pizza. And then that frame would point to the 2 other frames as actors. So that would be a meta claim, a meta frame, if you will, because it's connecting 2 frames.
I understand that. What I'm having trouble picturing is the and construction. We should have pizza and Chinese. It's not we should have pizza and we should have Chinese. It's we should have pizza and Chinese.
Right. And it's true that here I'm supposing that the frame schema of eating, if there's many food items, there's an implicit and that's totally contestable. We could imagine somebody else making a frame, but that would be part of the frame definition is what I'm saying, right? It's you could create your frame schema and the frame ontology so that it's an and or it's an or. I would tend to prefer and. You see what I'm saying? And then if it's an or, then you'd have to use a different construct and you'd probably have two frames. We eat Chinese and we eat pizza, and then a disjunction frame between those two. It's probably what I tend to do. But that's at the ontology frame design level, if you will. It's another layer. But yeah, I don't think that's at the notation layer to solve. I think that's at the frame design layer.
Right. No, yeah. But getting back to the example of the meta claim,
Yep.
let me see the notation there, right? If you have, I just want to understand which is the thing that's happening here, because
Yep.
if the subject is we, and the predicate is should have these objects, and object 1 is pizza, object 3 is Chinese.
Yes. And you
predicate 2 is we should
it's
we
about
should
only
go
the pizza
to
part.
Amici's, right? Okay, so construct the sentence for me using having those as an example.
Okay, so
because what I'm trying to get at is the way I would read it is like, you know, the fact that we should have pizza and Chinese means we should go to Amici's that serves both Chinese and pizza, right?
Yes,
it's
yes.
not targeting only the pizza part, and so I'm trying to figure out how
I understand what you're saying. Yes. The way I would tend to do it again is again pretty much not at the syntactic level, in that I would have
wait.
No, but let me still express it. Let me do
okay.
the syntax right I'm doing. I'd have one thing that says probably a frame, but let's do it in a binary one. I, like Marc-Antoine, subject, predicate wants to eat. I don't think that's the kind of predicate. I'd make that a frame, but let's say it's a binary predicate. Why not? And then I'd have two objects, pizza and Chinese. And then I'd have another independent claim that Amici serves and then pizza and Chinese as two objects, right? And then I'd have a meta claim saying the second frame enables the first frame, right? And this is where I'd probably actually use, let me think. And oh, you know what? You found a hole in my notation. Well, I mean, it can be done, of course, but that pretty much forces me to create identifier for my frames. And that's not necessarily what I want. I was hoping to do it with an inline frame, and that doesn't work either, because what I want to do, like, this is focusing on having the statement as the subject. And what I want is to have also a statement as an object. And that notation doesn't make that easy, unless, of course, oh no, it's fine actually. Well, unless it's a frame. Okay, it's not easy with the triple notation, it's easy with the frame notation. That's it. What I would do is say the subject, the object is, so I'd have enables, enabler serves Amici Pizza, and then the second one, blah, blah, blah. So, but what's interesting is that let me write it, because I think it may be an edge case and it may be a limit of my thing. I'm not sure either way, but I want to write it for that reason. No. You can put it here. Thank you. Yes, working with two screens. Enabler, and that's interesting because it's already a frame. That's why I wanted to distinguish, but it's a subject. Okay. So actually it's enables, enabler, that's the role, serves, who, Amicis, what, pizza, Chinese, and the other role is enabled, wants to eat, which I think is really weird. But no, what we want is subject, predicate, object. Let's have that actually. Marc-Antoine, or should I put you? Actually, we'd want two subjects, which would be even better. See, again, in the frame-centric notation, it's not a problem. Wants to eat the Chinese. You know what? This is crap. This pretty much has to be in frame notation. Wants to eat. Who? One. What? Pizza and Chinese. This works, but I'm not happy that I cannot do the other one. This should work. By the way, I still need the enabled. One problem here is the meaning of the conjunction is really like we're enabling both. No, that's fine, I guess. That's not the problem.
Yeah, this is an and here. It's not an or.
Yeah, but that's not the real problem. The real problem is it sounds like I'm enabled. It's not this is enabled. So that's wrong.
I see.
Here it's fine because here I'm implicitly creating an object which has these characteristics. But this is absolutely not working. There should be a grouping here. And so maybe I need something to, and that's why I was very uneasy to allow binary predicate at all. But obviously everybody wants binary predicate because they're convenient. But I probably need to distinguish the binary predicate, which is a special case, from the frame. Because the frame is really the important case, right? It's when you have, this is a frame. These are roles in the frame. That's fine. But the frame is kind of already a chunk. And maybe I need to have a different prefix for the frame as a unit. If I had a different prefix, it would be easy to say, let's say this is the What's a good frame prefix? No, this would be the frame prefix. Enabler, and then here we see that the subject is a frame. But here it's subject, predicate, object. No, this sounds like enable Marc-Antoine, who happens to, no, that's wrong. Yeah, using.
Well, no, because if you're switching a different notation, you know that's going to be a triple like that. Then you would take the triple as a whole. It enables the triple as a whole. So it enables Marc-Antoine wants to eat Chinese pizza in Chinese.
Yeah, yeah, but I think it should be possible to just to be okay in the turtle-like notation I was aiming for. If you're in turtle, and maybe I should have. I mean, this is for people who are familiar with turtle, and I should have explained that. It's very possible to always say subject, predicate, object. Well, I should subject 1, predicate 1, object 2, object 3, predicate 2, object 4, object 5, dot, and then subject 2, predicate 3, object 6. So this is the turtle principle. So you have subject, predicate, object, comma, object, comma, object, comma, object. And each of those is a separate triple. It's just a way to string on triples without having to repeat subject, predicate. And here,
I see.
Semicolon, predicate, object. Again, I don't have to repeat the subject because I've already said it, and the semicolon says, okay, we're still using the same subject, and I'm just stringing on a new predicate. And it's the dot that terminates the subject.
So it inherits, like I was thinking this was a metaclaim. It's instead just inheriting the subject from the same line.
Yes, yes. Exactly. And this is what I was aiming for here. It's just Marc-Antoine, and then independently, this is a triple. And it's perfectly fine to do that. But then this is not, if I want to treat this as a unit, I'm in trouble. Right?
But if you used turtle notation at that point?
Well, what I think I want to do is this, really. It's wants to eat. It happens to be a binary predicate, but here, because I'm in object position, if you will, what I'll do is make it into and I don't even have to have the new notation, really. It's a predicate, but I'm putting it in object position. So that means I'm treating it as the start of a frame. And then basically what I have really is subject object. Which are the two sides of the binary predicate arrow. And that's always valid. So yeah, not as elegant as I was hoping. So there's,
yeah, I don't know anything about the history of triples, and maybe for your video it's not worth going into. I'm just wondering what the logic is in general of the subject
no, but it's
object structure.
Listen, thank
like
you for your
subject. Yeah.
Thank you for your questions. It helped me uncover an ambiguity. I'm very happy. That's
glad I could help. Yeah.
Yes.
Glad it could be useful somehow.
No. This is very useful. Okay, but still, things to work. This is not as good as I wanted, but it's certainly not wrong. But because I still can express this, but I have to play up the binary relation as a frame to promote the binary relation to a frame, which is another bit of syntax. So I'll certainly change that. Or explore alternatives. This was a simplification of an earlier syntax I had, which I think handled that case better, but was not as terse. So I'll see if I can find something a bit better. So there'll be stages. Okay, the other thing I want to get into, and that's really the meat, and time is running, but we started a bit late. So if you don't mind, I'll go over it. So this is just a review of things we've discussed last time. The basic relations are, fragments are interpreted as immutable concept representations. Chat, let me just, okay, you have hard step, okay. I'm interested in equivalence classes between concept representations, aka definitions, aka, but I'm using concept representation right now as the name. It's a bit too verbose. Concepts are very mutable. And the question is, should they be materialized? And like I have a short version here, but a longer version next slide. There's, of course, still the many-to-many relationship between concept representation and symbols. And I insist on concept representation. What's the relation between symbols and concept? I think it should be inferred from that. And just as a name, because I'll need it, the set of concept representations named by a symbol, I'll call that the symbol semantic scope. It's just a name for the set defined that way. And eventually I'll want to distinguish notational, explicit, and implicit connotational, connotative scopes, but that's not there yet. In a perspective, in a local perspective, we can choose an ambiguous representative symbol for a concept. Should be a concept representation here. And statements reference entities. I won't be using that so much here. And distinction and abstraction. And here this is new stuff actually, the notion of abstraction as a set. Like when you make a distinction, you're saying this concept is a special case of that concept with these extra claims that are supposed to be definitional. And maybe you have examples, and that's what makes a distinction. When it is possible, not necessary, but possible, to define an abstraction as, well, these are go upwards on that relation. These are the distinct case, and they cover this thing. And you could even define the upper concept by the distinction. Now, again, same idea as we've said many times, is the abstraction a useful concept in and of itself? Like the good old example of many variants on climate change. Do we care or not about ocean acidification? And then yes, it's an abstraction. Are we never going to use the abstraction? And then I'm called that a concept union versus a concept cover, because you're trying to cover the original concept. Notion of improvement, improving a concept, and a very important special case is replacing an ambiguous concept by concept union, saying, we thought we were clear what we meant by this concept, or by this concept representation, to be more accurate, but actually what we want for the whole equivalence class is say, no, we actually mean this or that, and this is the concept union. And you should choose, because you probably don't mean both at the same time. And otherwise it's a cover. And that's the improvement. I used to call that refine, now I'm calling it improve. And the other one is, refine was ambiguous, and now I'm distinguished improvement, which is a different concept, and clarification, same concept with a better definition. Now, the important thing is what happens when a concept evolves. Concept representations are immutable. That's not a problem, but the concept changes. It can change because I'm adding a new definition in the equivalence class. I may be replacing the concept by a clearer version, not clearer as in same idea, different expression, but this was a bad idea. Let me define a slightly different but better, more useful concept and scrap the original one, please. So that's a case of concept evolution. That's the improvement relation. And one case of that specifically is when it's replaced by concept union. And that's the distinction and the disambiguation process. So concepts evolve. And so what we want really, the objective of all this is that we have a statement that refers to a concept. The concept's evolving. What happens to the statement? We need to be able to track that concept has evolved since this statement was expressed. And so should the symbol refer to the concept, which is the equivalence class, or only to the concept representation? Now, the advantage of referring to the concept is that if the concept evolves and being represented to a concept union, we'd want to update the back references to the original concept. Like any statement that refers to that concept, we should be able to say, oh, no, this could mean this or that, and let's update those as well so that they refer to whichever appropriate concept. But that means tracking all of them that talk about the concept. And if we refer to the concept representation instead of the equivalence class, the concept, then we have to actually resolve the equivalence class. Here are all the concepts, and then let's track statements for all of these concepts. So that's a bother. And we also have to know what were the equivalent concepts at that time, which is hard work. But actually, I don't think it's hard work, but I don't think it's worse than keeping track of the equivalence class evolution, which we would need anyway, because if we look at the concept as an equivalence class and then we fork it, we have to know something that was looking at the equivalence class before it joined or after it joined, or something might have been declared distinct afterwards. So there's many things that can happen in the relationship between concept and between concept representation and concepts. We have to keep track of that anyway. So I'm not sure it's making it harder. On the other hand, equivalence relation is deemed true or deemed false within a perspective. So the equivalence class exists within a perspective, they're local. And that's why I'm very uncertain about materializing them. So what I'm saying is statements, because of progressive formalization, they'll start with symbol references, but we should resolve them to concept representation, not to equivalence class of concept representation, not materialize the equivalence class and point to the concept. And then when we need to update the concept, because it's not just the representation, it's the equivalence class we're updating, well, what we'll do is at that moment resolve the, here was the representation I had, here's the equivalence class at that time, and here. It's more work, but I think it's more accurate. Now, if you're okay, so if you're not working within a perspective, what you're looking at is all statements, like what are the operations you're likely to do? You have a concept reference, you want to know all the statements that refer to that concept reference. But more likely, what you'll want is all the equivalence relation paths from a given concept reference, which will give you the equivalence class. And then all statement referring to any one statement in that equivalence class. And also all distinction, improvement, clarification that either point to a concept reference, point from a concept reference more often, or if you apply that to the equivalence class, you'll want distinction, improvement, clarification that point to the class, point from the class, or point within the class. So those are all plausible use cases, exhaustive use cases. And finally, all symbols which name a given concept representation or equivalence class. Now, those will probably be huge. They may have contradictions. They may have whatever. That's the kind of the primitive layer one, if you will. But I think most of the time you'll get huge sets out of that. Most of the time you'll be working in the truth layer. Here I'm saying since we're looking at social truth values, well, there's probably going to be many social truth value models, but here I'm just starting with a simple one with true, false, unknown, contested, with fairly obvious semantics. I have the truth tables later. Let's not get into that. So it should be possible to notice contradiction. Like it's okay. First, we can define subsets. Like I'm in this perspective, so I'm just looking at the deemed true statements. I'm just looking at deemed true plus contested, or plus unknown, or both, and the non-false. So these are all possibilities. And then when you have these sets, you can ask, okay, in this subset, do I have contradictions? Do I have, for example, concept representations that are both the subject of a deemed true equivalence relation and a deemed true distinct relation? Then there's a contradiction. If the deemed true subset of improvements should be acyclic, you should not have a cycle of improvements within a perspective. And a symbol cannot be a preferred representation for two distinct concept representations. It could be the same, of course, for two concept representations.
Preferred. You mean preferred? It can't be a preferred representation.
Yeah, absolutely. So if there's a contradiction in the true statements, then we definitely have to correct it. But what's interesting is we can also say, let's look at the non-false ones and let's see if any of the unknown or contested things would introduce a contradiction. And then what would we do? We could say, well, this one introduced a contradiction, so we'll mark it false. So that's one way of treating it. And this should not be automated. This should be a human operation. But I think it should be interesting to say, okay, run a query as if any contradiction inducing statement were considered false, or run a query saying which are the ones that I would have to mark false to avoid contradictions. And the other possibility is to, instead of negating the contested statements, is to do the reverse and to say, well, the statements that were deemed true that are in contradiction with a contested statement, well, now they're also contested. And I think that's also useful to do in some circumstances. So it should be possible to view the set of true statements using either of those, or set of statements using either of those, and that enables one to make a kind of curation of statements. And this is where I'm still a bit stuck, and why I don't have examples yet. It's like, what does it look like? I mean, what it looks like really is on the wire, like not with my toy input notation, but on the wire, is if I'm asking, like there's useful subset, right? Give me all the statements that are supposed to be improvement on all concept representation that are supposed to improve in a given concept representation. That's a useful query. That's something I want to know. Well, there's many of them. I'd like to be able to say, well, first get the clearest. You know, the clarification would be a partially ordered set. I could get the maxima and weed down that way. Improvement, same thing. There's a partially ordered set there. Semantic scope. I'd like to get, when I'm asking, what are all the concept representations for the symbol? Maybe I'd like to get one per equivalence class rather than everything. And So there should be ways to kind of minimize the result set. And the result set should also come as, here are the concept representations, but here are also the relations between them that make the, that justify why we gave you that structure. So here I'm a bit unsure about how to represent that on the wire. I could just dump everything, and it's well defined enough that I can just dump everything and let the client sort it out. But I don't think that's useful to the client. So this is where I really need help in saying, what would you expect to get on the wire given this, that this is the data structure? I'm still struggling with it, though I mean, I think saying I want the list of these concept representations and the relations with defined as I defined it and with the restrictions I'm giving, it's probably good enough, but I'm feeling it must be possible to make it not more terse, but more, what's the exact ultimate value you want? Or is there a metric that's useful to you? Or can I give them to you in an order that's more useful to you? I'm really interested in order. Like, is it the most likely, like the most true first? Things like that. So this is what I'm still struggling with. Can I well order this? So that's where I'm at. But I think everything here at this point is well defined enough. As I add the relations definition. I know you have to go.
Yeah, I need to get going. And there's also some mayhem here at home. But
okay.
Yeah.
Chat to me if you found a glaring hole in what I said, and I'll try to put a link to this even in its terrible state, and then I'll improve it. Okay.
There's a lot of, but yeah, it all makes sense to me. I've gone through kind of similar thinking, not to the depth you have, but I'm on the same page in terms of those questions. So
good.
Yeah,
that's reassuring. Thank you. Have a good one.